Hello guys, this is Vijaynath Vishwanathan and welcome to Code with Vijay. Today I'm going to tell you that I'm going to create and host a web application. That is not a big deal, I know, that's not a big deal at all. But I'm going to tell you that I don't have an application server or a web server either to host the web application. Really? Is it possible to do? To host a web application without an application server and a web server? All right, I'm going to tell you again that my application is going to connect to a database. I'm going to keep some data to database and I'm going to fetch data from a database. But I don't have a database server either. Are you kidding me? Of course not. Of course I'm not kidding you. That is exactly what we are going to see today, the power of serverless computing. So guys, the plan is to create an application from the very scratch, but completely serverless. Okay, we are going to create an application by using or by consuming few AWS services. Okay, as I told before, we'll not have an application server, web server, or a database server. So this is not a theoretical session. So we are going to create everything from very scratch. Okay, but before jump into building application, I just want to tell you what serverless computing means and what's the benefit of serverless computing. Okay, so let me tell that now. So what is serverless computing? Serverless computing allows you to build and run applications and service without thinking about servers. Okay, basically you don't need to spend time and resources to purchase and set up the server. Okay, if you're a developer, you just concentrate on your development task, and remaining everything will provided by your cloud provider. Okay, so you don't need to think about setting up the infrastructure which is required to run your code. Okay, serverless applications don't require you to provision, scale, and manage any servers. Everything will do by your cloud provider. Okay, you can build them for virtually any type of application or backend service, and everything required to run and scale your application with high availability is handled for you. Okay, so the scale up, the scale out, and all those infrastructure kind of thing will managed by the cloud provider. Okay, if you are hosting an application to your own web server, then you have to do everything. You have to depends on needs. You have to scale up your application, you have to scale out your application, you have to purchase new servers which is required to satisfy your new needs of the customers and all those things. Okay, but in serverless computing you don't need to worry about all those things. You just develop the application and remaining everything, and just upload the application to the cloud provider, and your cloud provider will take care of all the infrastructure setup. Okay, building serverless application means that you developers can focus on their core development instead of worrying about managing and operating servers. All you need to do is concentrate on the application that you are building and completely concentrate on that. Okay, and once you complete the development, just upload your code, and remaining everything will take care by your cloud provider. Okay, so that's the long story short about serverless computing. Now let me show you the plan what we are going to build today. Let me show what all the different AWS services we are going to use to create our first serverless application. All right guys, so this is what we are going to build today: a small little web application to store employee details. We are going to store employee first name, last name, and email address. Okay, we are the one in yellow background. These are the different AWS services we are going to use to build our serverless application. If you guys are not aware about any of these services, please don't worry at all, because you don't need to know each of these services in detail. But if you're interested to know more, I already have videos on these services. Apart from DynamoDB, I have videos on S3, API Gateway, and Lambda function. I would recommend to go and watch that, but not the scope of this course. For this course, I'm going to explain everything. Okay, so let me explain the architecture what we are going to build today. So we'll have a HTML file that we are going to keep in AWS S3. S3 is a symbol storage service. So that's a service, where we can store our files, basically objects. There we cannot store blob, or we cannot run a database server or anything. That is just static storage. We can save documents like PDF documents, Word documents, HTML files, and all that kind of documents we can store in S3. So that is the place we are going to keep our HTML file. So whenever a user clicks submit button with data, that will call an API that will host in API gateway. So the concept of API gateway is to expose a REST service to outside world. Okay, API gateway will not have business logic or inside API gateway. Okay, the whole basically it will expose API. It will not run any business logic. The actual business logic we are going to create is in AWS Lambda. Okay, but in API gateway we can do many other different things, like authentication of the user, authorization, or validating the input that user passing to the API. All that kind of thing we can do in API gateway itself. Okay, from API gateway we'll make a trigger to AWS Lambda. AWS Lambda is the actual serverless function. That is where we are going to run our business logic. Lambda is basically event-based functions. It means it needs an event to trigger. So API gateway is one of the trigger for Lambda to execute. For example, when a user clicks submit button, it will call the post API that will trigger Lambda function. Okay, inside Lambda function we'll do our business logic, and we'll connect to DynamoDB, and that's where we are going to store our data. DynamoDB is a NoSQL database. It means it is not a relational database. It will not have the concept of rows, columns, or primary key foreign key relation. It will not have any of that concept because that's a NoSQL database. Okay, and after we store our data, then we are going to get data using email ID. Okay, the flow is exactly similar, but other way around. Instead of posting or instead of saving data to DynamoDB, we are going to get the data that we have already stored in DynamoDB. Okay, so the steps we are going to do is like this. Initially we'll create our first API in API gateway. So we are going to the first API we are going to create is get API. Okay, then instead of connecting to Lambda, what we are going to do is we'll return a mock response from API gateway, because we want to make sure that the API that we have created is working fine or not. Okay, and if it is working fine, then we will connect API gateway to Lambda function. Okay, here and then we'll return a mock response from Lambda function. Okay, then again we'll test that API. Actually we are going to use a REST client called Postman. Okay, and once we are getting data from Lambda, then we'll create a table in DynamoDB, and we'll configure a sample data. Okay, then we'll connect Lambda to DynamoDB. Okay, and again I'll test the API. This time I should get data from DynamoDB. Okay, that's the first API get, and after that we'll do the same steps but for post. Okay, and once these three components, API gateway, Lambda function, and DynamoDB is ready, then we'll create our HTML, and we'll host that HTML in well, actually that is not hosting, but now for simplicity, assume that is hosting. Anyway, after that we'll keep our HTML file in AWS S3, and from there we'll connect to API gateway for get and post functions. Okay, this time instead of using Postman, we'll save data using the actual buttons, basically submit and get employee details. Okay, That's the steps we are going to do today. And once all these components are working fine, then I would say we have built our first serverless application. Okay, that's a plan. So too much of theory. Now let's jump straight into hands-on lab. Okay, so for this to run or for this to try it on your own, you need an AWS account first. You don't need you don't need any account. You don't need to pay for any account, because the Freeter itself will have lot many free usages, so that itself will be enough for you to try it on your own. Okay, so let's jump straight into the lab. Before start building the application, let me update you one more thing, that we are going to build this application as two different parts, and apparently this video also will have two different parts. Part 1 of the video, we are going to concentrate complete end-to-end functionality of get operation. Okay, then in part 2 we'll focus on submitting data through front end, then we'll test both post and get. Okay, so please subscribe my channel and stay tuned for part 2 of the video. This one will be part 1 of the video. Now let us start building. So I have logged into my AWS console, and here we can search for API gateway. So as I told before, the steps we are going to do first, or the step we are going to do first, is to create an API, basically a get API, and we will test that API with mock response. That's the first thing we are going to do. Okay, so let us create the API. Get started, click OK, and select new API. And you have to give an API name. Okay, so let's say get employee details by email, for example. Okay, so I can give a description as well, but that is not mandatory. Create API. Okay, while doing production code, or while exposing a production API, give proper description. But now, as this just a lab, I'm making it pretty simple, but don't skip description, because it should define what your API is doing. Okay. So it will take us to this window. So the first thing we have to do is to create a resource for the API. For that, click here and create a resource. Okay, and give a resource name, the same, get customer details by email. Okay, and it will automatically take that as the resource path and create resource. Okay, before that, there is something called enable API gateway course. Course means cross origin resource sharing. So what does that mean is, say your API is in one domain. Okay, and say if you're trying to access that API from another domain. Okay, for example, say your API is in say www.api.com. okay, and you're trying to access that API from say www.abc.com. okay, if you want to connect your API from www.abc.com to www.api.com, which is where your API is, then you should enable cross origin resource sharing. Okay, so that's what cross origin resource sharing means. So what we are going to do is to connect our API from S3 bucket. Okay, so that will be in different domain, and your APIs will be in different domain. So that's the reason I'm going to select that. Okay, create resource. So now you can see the resource has been created. The next thing to do is to create a method. So that will be our actual web method. Okay, so the web method will be under the resource. So I've already created resource. Next next step is to create a method here, create, and here it will display all the possible HTTP verbs. Basically you can select any if you want any, then delete, get, head, patch, post, put, all these are HTTP verbs, but the one we are going to create is get. Because of that I'll select get here. Okay, click here. So next thing, it will ask which integration we want it to be. How do we want to integrate our get API or the API that we have just created. Okay, as I told in the introduction, API gateway will not have any business logic on its own. It will do different other things like security things, authorization, authentication, checking validity of data, and all those things it can do. API gateway can do, but it will not. It cannot execute any business logic. Okay, for that we have to connect our API to any other kind of integration. It can be Lambda function. That is what we are going to do today, but not now. Once we create Lambda, but here now we are simply going to return a mock data. Okay, another integration point is HTTP. Basically, you can expose any web services in any other servers, and you can call that HTTP method from here. Okay, next one is mock. That is what we are going to do now. And the other one is any other AWS services. Say if you want to connect to S3, okay, or like that, any other AWS services, then you can select that. Okay, so the one we are going to do is create a mock response. Because of that, I'll select mock. Okay, and click save. Okay, you can see the path or the execution flow here. When first hits to get method, it will come to method request, then it will come to integration request, then integration response, method response, because API gateway itself has scope of a full course, so I'm not explaining each one of that, because that is not the scope of our the project that we are going to do now. Okay, because of that we are mainly focusing on what we want to achieve today, so not the complete services as such. Okay, so one thing, as I told, I want to do is to return a response. Okay, a mock response. So that is what I'm going to do now. Select integration response. Okay, and expand this section and expand body mapping template. You can see there's already a content type defined for that body mapping template. Select that one and generate a template here. So you can select any one of the existing thing, empty or error. Okay, but we are going to return a custom response on our own. So that will be a sample JSON that we are going to create on our own. Okay, so the JSON would be first name, Vijaynath, and last name Vishwanathan, and email. Vijay at gmail.com. Okay, so this is the mock response. We are going to send it back to test this API is working or not. Okay, let me save it. Okay, that is saved, and save everything. Okay, the next thing to do is to deploy this API, because to test this API we need an API URL, right? So to get that URL, you have to deploy this API. Okay, in fact, after doing any changes, you should deploy that API to reflect that change. Okay, it's very easy to deploy it. Click here, and say deploy API. Okay, you can create multiple stages of your deployment. Say if you want to deploy in your development, then you can create a stage for dev. If it is UAT or system test like that, you can create different stages. Okay, the one I'm going to create is stage one, development one. So the stage name is dev, and give description and deployment description. Okay, I'm leaving it blank now, but while you're doing in real time, don't forget to give description, stage description and deployment description. Good, that's all good practices, and deploy it. Okay, now we can see this URL. So this is the invocation URL to access our API. So one thing to keep in mind is this URL, that's the root URL. If we try to access that, that root URL will not get anything, because that root along with that root URL we have to append our methods, HTTP methods basically. So let me show that. If I copy this one, okay, let me open Postman here, and if I'm trying to get this one, I'll get an error here, missing authentication token, because that is a root URL. So we have to get the HTTP method that we have created now. Okay, so the HTTP method we have created is get customer details by email. Okay, so let me add get details by email. Okay, now when we get this one, I should get the mock response that I have created. Okay, let's try. So you can see it is returning back the mock response. So it means our API is working fine. So the next step we should do is to integrate our API with the actual business logic, or the place that we are going to write actual business logic, that is a Lambda function. Okay, that's the next thing we are going to do. Okay, so next step is to create a Lambda function. So in AWS console, search for Lambda. So you'll get a window like this. If you don't have any Lambda functions created yet, then you'll get a window like this, and there's a button to create a function. Click on create function. It will take us to this page. There are different templates available to create Lambda function based on your requirements. Okay, so all these are different templates. Okay, but the one I'm going to create is from the scratch, basically a blank function. So to do that, click on order from scratch, this button, and when you click that, it will take us to this page. So there are a couple of record fields. First you have to mention a function name. So here get customer details by email. Okay, then next step is to select a role. Okay, role basically means the level of permissions you want to give to your Lambda function. Okay, you can give any minute level of permissions in Lambda. One example is, say in your organization, only people in the HR team should be able to access your Lambda function. Then you can do that kind of privilege. Okay, either you can select an existing role. If you already have a role created, then you can select that role. Okay, or you can create if you don't have a role, then you can create one on your own. Okay, I'm not going to create a role from here with the create new role, because I want to show you how to create a role in identity and access management. That is another AWS service. Okay, so let me take you to IAM, because to create a role is something really important for security perspective. So you should know how to create a role. Okay, so let me hold this window here. Okay, I'm going to open another AWS console. There I'll show you how to create an IAM role, and how we can attach policies into the role that we are creating. Okay, so let me do that now. Okay, I have opened another AWS console. The service I want to find here is IAM, that is identity and access management. Okay, here you can see roles. So what we are going to do here is to create a new role. Okay, that new role will have two permissions. One is Lambda function full access. Okay, but depends on your requirement. You can give any minute level of permissions. Okay, so I'm going to give full access just for simplicity. And the next permission I'm going to give is DynamoDB read-only access. So the reason I'm going to give only read-only access, because the operation we are going to do is a get operation just to read data. Because of that, I don't need any other permissions. So that's a two permissions I'm going to give to this role. Okay, so click on create a role here. Select which function do you want this role to be. That's for in our case that is Lambda. Select Lambda, click on next permissions. Okay, here it will display all the existing permissions. Okay, we can attach that permission to this role. The first one I'm going to search is Lambda, so you should be able to see something, say Lambda full access. Select that one, and the next one would be DynamoDB read-only access. Select that one, click on next, review, give a role name here, say get customer details. Okay, give a role description. I'm going to leave it blank now. Click on create a role. So now we can see that role has been created. Okay, the next step is to attach this role to the Lambda function. Okay, now let me jump back into that Lambda function now. So now I should be able to see the role which I have created when I select choose an existing role. But before that, let me refresh the page once. Okay, that will clear off the function name. Okay, now the one selected is choose an existing role, so I should be able to see. There you go. This is the new role we have created. Select that one, click on create function. So that will create the new Lambda function. Okay, so next what we are going to do is to return a mock data. Basically the data, the JSON, the mock JSON that we have created before. We are going to respond that from this Lambda function. Okay, then we'll connect our API gateway to Lambda function, and we'll test the API again. And this time, we should be able to get data from Lambda function, not the mock response from API gateway. Okay, so let us try that. Let me delete this data and let me paste this JSON. This is exactly the same JSON that we have created before. Okay, and click on save and test. So this test means it will test this Lambda function alone. Okay, basically when I test this, I should be able to get mock data. Save and test. Okay, you can see here it is returning the JSON that we have configured inside the Lambda function. Okay, so Lambda function is working fine. So the next thing we want to do is to connect Lambda function from our API gateway. Okay, so let us do that next. To connect one AWS service to another, you need something called ARN, that is Amazon resource name. So when we generate this Lambda function, there should be an ARN generated. So let me go and copy that ARN, because we need that ARN to mention, to specify in our API gateway. Okay, so let me copy ARN. So you can see ARN, again ARN means Amazon resource name. You can see ARN here. Simply copy that, copy it. Okay, now let us go back to API gateway. There we can connect to Lambda. We can basically we are going to delete the mock response that we have configured in API gateway, and there we are going to integrate with Lambda function. Okay, so let us do that. Go to API gateway. Okay, this is the one we have created before. Click on that one. Okay, and click on select get here. Okay, let us clear the integration response that we have added before. Go to integration response, expand that, body mapping template, and click on this one and clear it, because we don't need mock body mapping template anyway, because we are going to connect to Lambda function and we are going to get data from Lambda function. Okay, because of that I'm clearing that. Click on save, go back to get again. Okay, this time we are going to change the type from mock to Lambda. Okay, so select integration request. Okay, select Lambda function. Okay, and select which region your Lambda is in. Okay, mine is in US East one, so let me select US East one. Okay, then there we can see the Lambda function that we have created in that region. So select that, click save. Okay, then we'll get a warning. Are you sure you want to switch to Lambda integration? Yes, obviously we want to integrate with Lambda. Okay, click OK. Okay, another message: you're about to give API gateway permission to invoke a Lambda function. Okay, that's fine because that's what we needed. Click OK. Okay, so at this point integration is fine, but still we should not be able to see the changes in our API gateway. The reason, because we have to deploy it, okay, to reflect the change. If you do any changes to reflect that change, you should deploy API. Okay, so let us deploy this one, deploy API. Okay, we already have a stage created before. Select that one, deploy. Okay, now when we test it again, I should be able to get data from Lambda, not the mock response. Okay, but probably we can't differentiate because we have given same JSON. What I'm going to do is test it once and I'm going to modify data inside Lambda function. Okay, then I should be able to get the modified data from Lambda function. Okay, so let us go and test this in Postman. So I have opened Postman again. Let us test it again. Okay, we are getting the same JSON. You can see the data here. Okay, now let me go and edit something inside Lambda. Then I should be able to get the edited data in Postman. Okay, so come back to the same Lambda function we have created. Now what I'm going to do is I'm going to modify this data to a very simple data. Simply say hello and say I'm from Lambda. Okay, we don't need to test that because we have already tested Lambda before. Simply save it. Okay, now I should be able to get this data instead of the JSON that we have seen before. Okay, let us try. Okay, click send. So you can see now it is responding from Lambda. So the our integration with API gateway to Lambda is working fine. So two components are integrated fine. The next step is to connect DynamoDB from Lambda. Okay, at that time we should be able to see data from the table, basically from DynamoDB, not the mock data from Lambda function. Okay, so let us do that next. Alright guys, I have logged back into AWS console again, and the service we want to find here is DynamoDB. That's where we are going to create a first table to hold first name, last name and email address. So let us select that. So you'll be able to see an option called create table. So let us create table. Okay, there we have to mention a table name, say customer details. Okay, next one is primary key. In DynamoDB that's called partition key. It is somewhat similar to primary key in relational database, but not exactly. But for simplicity, now you can assume that as a primary key, like in relational database, to add to uniquely identify a data. Okay, Okay, so in our case, primary key would be email ID. Okay, and the data type would be string. And you can see something called sort key. We don't need that now, but I'll quickly tell what sort key is. It's like composite key. You can make a combination of key as primary key. So that's a concept of sort key. We don't need that now. So we have given table name and email address. Okay, then create. So it will take some time to create the table. So now the table has been created. You can see here custom details. So the next step is to add a sample data to our table, the one we have created now. Okay, this is to test the get API we are created. We just want to check, are we getting data from DynamoDB instead of any kind of mock responses. Okay, but once our post API is ready, then we will send data from our front end to DynamoDB. Okay, then we'll get the data that we have saved with post API. Okay, for now let me add a sample data. Click on items here. Okay, you can see here create item. Click on that one. Okay, the partition key that we have given is already created there. We need to give a value. So say email ID is code with vijay@gmail.com. Okay, next we need to add fields for first name and last name. Let us do that. So insert, and the data type is string. Okay, and the field name is first name, value is and then we need to add last name. Insert string, and the field name is last name. Okay, so we have added all the needed fields. Let me save it. Okay, now you can see here one item has been added. Okay, so the next thing to do is to get data from DynamoDB from Lambda, and we'll test the API, the get API we have created again. This time we should be able to we should get data from DynamoDB, not any kind of mock responses. We'll delete all the mock responses basically. So we should be able to get data from here from DynamoDB. Okay, so the next step is to write some code in Lambda function to connect to DynamoDB, and let's see how it's working. So now I am the Lambda function that we have created before. Now let us add code to connect to DynamoDB. Okay, so let us write some code. I'll explain code while I'm writing. So first thing we need to do is to get AWS SDK. Okay, so basically there's an npm package. If you're doing outside AWS console, say if you're doing in Visual Studio Code or any other editor, then you have to install that SDK through npm package. But if you're writing code inside AWS console, then you don't need to install any npm packages, because by exporting this code, Amazon itself will take care of importing all those packages. Okay, so the first thing to do is to require SDK package. Okay, so let's do that. Say constant require. Okay, now we got that package. Okay, now from SDK package we have to take DynamoDB document client. So the reason I am writing this outside the handler function, because that's the way because of the way Lambda works. Basically, behind the scenes Lambda works like a container model. because whenever some hits comes to Lambda and that exception completed, it will maintain something. So anything outside the Lambda will keep for some time. Then the next subsequent request, it will not create that part again. Okay, so if you're keeping inside handler function, then every time it will recreate again. So that will take some time to set up the creation. So it's a good practice to make the things which we can reuse outside the handler function. For example, say connection to database and all those things we can keep outside handler function, then it will not recreate every time. Next thing we want to do is to create a document client. Okay, say doc client equal to new AWS DynamoDB dot document client. Okay, now document client is ready. You can go to AWS official documentation. There they have a few examples on how to connect to DynamoDB and all. You can check in official documentation as well. So the next thing to do is to define which table name we need to connect to. Okay, so our table name is, let me copy it from here, that is customer details. Okay, and the next thing to do is to create some params, because we are going to get data with email ID, so we have to pass that as params to DynamoDB. Okay, also in the params we have to mention the table name as well. Okay, so let us do that now. Let us create the params which we need to pass to DynamoDB. So where params equal to the first one would be table name, that we have already defined outside, that is table name, this one. Okay, and the next one would be the key, in our case that would be email ID. So that key will pass from the API gateway. So the key name would be email ID, or you can give whatever the key name. In our case that would be email ID. Okay. Say email ID, and that would be the one we are passing from the API gateway. Okay, so here it would be event dot email ID. The reason event dot email ID because this is the object we will get the data that we are passing from API gateway. So in that JSON structure, our field name would be email ID. So that's the reason I have given event dot email ID. Okay. Now now we have created the params. The next thing to do is to call document client dot get. So that's a API which will connect to DynamoDB. Okay, and we will pass these params to that get function. Okay, basically DynamoDB API's get function, and we'll get the data back. Okay, for that doc client, that's a client which we have created created here, this guy. Okay, doc get first parameter is params, that params is this guy. Okay, the next one is a callback. Data. Okay, inside that callback we have to call back, so this callback would come here, and this would be the actual data. Okay, and if any error happens, this returns error. Okay, one thing to remember is this key value that should be the key that should be exactly equal to the key in DynamoDB. It is case sensitive. Okay, so if you come here, our key here is email ID. Okay, so it's better to copy from here. Okay, see, I have given lowercase d. Let me correct it now. So now our key is ready. So the next thing to do is to test this function from here. Okay, let us see that. So we have to create a configure a test event. We can edit this one. So the data we need to pass is email ID, and the value is codewithvijay@gmail.com. Okay, let us save that and say test. Now we should be getting data from DynamoDB. Let's see. So we can see green, it means that's running fine. So we can see the item we are getting back properly from DynamoDB. Okay, now let me change this data to some invalid data. Okay, say abc.com. This time we shouldn't be getting data from DynamoDB because it couldn't find a matching record. So when we test it, okay, you can see an empty data because it couldn't find any matching records in DynamoDB. So our Lambda function, which is connecting to DynamoDB, is working fine. So the next step to do is to test it from API gateway. Okay, we don't need to do any change in API gateway because we have already connected to this Lambda function. Okay, and only thing we have changed is to the code, which is from mock response to connect to DynamoDB. Okay, so let's go and test this in API gateway now. Sorry, one thing I forgot to tell you is before I told we don't need to do any change in API gateway, but we need to do some settings. The reason because we are going to send a parameter that is email ID to our get API. Basically we are going to send it as a query string, so we have to receive that query string in API gateway to pass it to our Lambda function. So we have to do that change now. Okay, so let me do that change and deploy the API again, and we'll test that. Okay, so let me go and do that change to receive the query string parameter from Postman. Apparently we'll change that front end later, and to receive that query string parameter in API gateway and pass it to Lambda function. Okay, so I'm in AWS console again. Let me go to API gateway. Okay, let me go to the function that we have created, and this get over here. Okay, there we can do multiple things. First of all, we can configure query string, that's a required parameter. It means whenever somebody is trying to access this API without query string parameter, it shouldn't work. Okay, we can set up that first. So in method request, we can say URL query string parameters. We can there is no query string parameters configured yet. We can add one. So the query string we want to pass here is email ID. Okay, and we can make that as required. Okay, if we are making that as required, we'll get a warning here. It means basically we have marked that some query string parameters as required, but the request validator assigned to this method is not configured to validate parameters. To ensure that incoming HTTP request include the required query string parameters, select an appropriate request validator. Okay, basically all what we need to do is in this request validator, select validate query string parameters and headers. Okay, right. So now when somebody trying to access this API without a query string parameter, will get an error back. So that is set. Now we need to take that query string parameter out and to pass that to a Lambda function. Okay, So in API gateway, there is a concept called body mapping template. Basically, you know, the whole idea behind body mapping template is we can map the body the way we want, depends on the input parameter that user is passing. Okay, say you know, say in our lambda function is expecting email ID alone, and the user is sending few other data along with the request, then we can, you know, skip all other data and we can just take email ID alone and we can pass that lambda. Okay, all that body mapping we can do it here. So in integration request, when you come down here, body mapping template, okay, you can see so if you don't want a body mapping template, we can select never. Okay, then I'm selecting this one. When there is no templates defined, that's a recommended one, then I need to map my body. So here in application JSON, can come here. Okay, so the way to take is, so we need email ID from the body that is passing. So email ID, so that email ID actually will come as a part of a query string. Okay, so I'm going to take that out like this. Input dot params email ID. Okay, so like this params means basically that query string params you're passing, and from that we are taking the email ID out and assigning to this email ID. Basically, you know, we are passing a JSON string, I mean basically JSON data just with email ID alone. That email ID is the email ID that we are passing as the part of query string. Okay, let me save that and let me redeploy this one. Okay, now that has been deployed. So let me go back to Postman again and let me test this API. So I'm in Postman now. Let us try without a query string parameter first, and let's see what is the message we are getting. We are expecting to see you know, a required field validator kind of error message back here, because we have configured API gateway to you know, accept query string parameter and that is required. Okay, so when I test this now, I should be getting a message back, missing required request parameters email ID. So it means we have to pass this email ID. Okay, so let us pass that now and see how it is working. Okay, so params here, and the value is code with Vijay at gmail.com. Okay, so when we test this now, we should be getting the data that we have configured in DynamoDB. Okay, let's see that. Okay, you can see that is returning first name, last name, and email. Okay, now let us try with an invalid data that is not there in DynamoDB. Okay, so there you can see you know, it is returning an empty data back, because basically Lambda couldn't find any matching records in DynamoDB, that's why. Okay, now let us go and change data in DynamoDB, and let's see the changed data is reflecting here or not. Okay, let's do that now. Okay, so I'm in DynamoDB now. Let's go and edit that record. Click here and edit. Okay, I'm going to change you know, this value from email address. Okay, first name to say, or say hello and code with Vijay. Okay, let us save it. Now you know, this data has been changed. When we are trying to get data from API, sorry, from Postman, we should be getting the updated data because we have changed the data. Okay, let's see how it's working. Let me go back to Postman, and here the field is called with Vijay at gmail.com. Okay, send the request, and there you go. can see first name has changed to hello and last name to Code with Vijay. Okay, so now 3 components are ready. We are able to connect from API gateway to Lambda to DynamoDB. Okay, now we have to set up the last component, that is the front end, basically HTML, and we should be able to get data to front end. Okay, so that's the next bit left. So let us go and do that now. Alright guys, so this is our small little front end. So as you can see here, there's a text box to search the key, that is basically the email ID, and you can see a button that is to get customer details. And once we search with an email ID, and if that data is there in DynamoDB, then we should be able to see first name, last name and email address from DynamoDB. Okay, now let me show the HTML for this one. So this is the HTML. You can see here I have an input control for search key, and basically labels for first name, last name and email address. And this is the data bind for each of these properties. I'm using Nocode.js for data binding, but you can use any other JavaScript libraries like AngularJS, or even you can use classic JavaScript, and you can use classic Ajax XML HTTP request to get data. So here I'm using jQuery Ajax for get call, and you can see the view model and the properties that I have binded here. Okay, so anyway, I'll upload this code to GitHub, and I'll share URL by end of this session. One thing we need to update is the get URL. So that is the same get API that we have created before. Okay, so let me go and copy that, and after that we'll upload this HTML along with Nocode.js file and jQuery file, and we will host that in S3 bucket. Okay, once after we host that, we should be able to access our small little website through browser. Then we should be able to get whatever data we are storing in DynamoDB. We should be able to get that. Okay, so first things first, let me go and copy the API URL now. So I'm in Postman again. Let me copy the API URL that we have created before. I don't need query string here because I'm passing that in my code. So let me copy that and paste it here. Okay, save it. Okay, before host this to S3, you always remember one thing to do, that is to enable CORS. We have already enabled that in our API gateway, but let me show that once again, because that is pretty very important. If you're not enabling CORS, then basically you're not able to access your website. Okay, so let me go and do that again to make sure that we have enabled CORS properly. Okay, let me log into my AWS console now. I'm in API gateway console now. Before we have enabled CORS while we were creating the API gateway. Okay, say in case you forgot to enable CORS at that time, okay, and you have created your resources, methods and everything, then if you want to enable CORS, it is pretty very easy. Select the route, click on actions, and there'll be here you can see enable CORS. Select that one and click enable CORS and replace existing CORS headers. Click on that one. Yes, replace existing value. Okay, so basically it will override the CORS. If CORS is not enabled, then it will enable CORS. Okay, now we made sure CORS has been enabled. Okay, now let me go and upload my files to S3 bucket. Okay, before uploading, I'll show you how to create an S3 bucket and how we can give permissions to public, because we are going to host a static website, and as that is a website, the whole contents inside that bucket should be accessible by the public. Okay, so we need to give public permission to that bucket. Okay, So let me go and do that now. Alright guys, so I'm in AWS console again. So let me go and create a bucket in S3. Search for S3 here. So you'll get a window like this. So let me quickly explain S3 bucket again. So S3 bucket is the place we can store objects, okay, basically files like movie file, PDF document, Word document, and all that kind of file. But in S3 we cannot store blob storage or a operating system. We cannot store such kind of things. Okay, basically we can store object. Okay, S3 also has the capability of static website hosting. So we are going to consume that capability to host our static website. Okay, so the way to do is click on create bucket. Then we should give a bucket name. Bucket name is unique globally across. It means if you are going to create a bucket called test, and if test is taken by somebody, then you should not be able to create the same bucket here. The reason because bucket name is globally unique across. Okay, so let me give a name that shouldn't be taken by somebody. Okay, let me try code with Vijay, say customer details. Okay, hopefully that will be available. Click on next. Yeah, that is available. Click on next. Okay, click on next, create bucket. Okay, there you can see it has been created a bucket called code with Vijay customer details. Okay, click on that one. So now you can see there is no objects. You can see basically the bucket is empty. So the next step is to upload our files to this bucket. Okay, so let us go and do that. Sorry, but before that we have to enable static website hosting. Okay, let me show that how to do. So here you can see an option, static website hosting. Click on that one. Okay, then you'll get different options, and select this one, use this bucket to host a website. Click on that one. There we have to mention our default page. Okay, so let me give the same name here, index.html, and if any error happened, which page to display. Okay, that is this one. Okay, as we don't have any error page now, let me give the same name itself, but it will be good to have a separate error page. If any error happen, we can show that error page with a default error message. Okay, that is ready. Click save. Okay, now our S3 bucket is capable of static website hosting. So the next bit to do is upload our files to this S3 bucket. Okay, so let us go and do that now. So go to overview again. You'll be able to see a button to upload. Click on upload and select add files, and these are the files to upload. Basically the one is index.html, then nocode.js file, and jQuery file. Select all of that, click open, next, 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 and upload. Okay, so it will take a couple of seconds. There you go. So now you can see the whole files are uploaded here. Okay, and the URL to host our website would be this one. So let's copy this. Okay, and now we haven't enabled any public permissions. Okay, because of that, if you're trying to access that URL, we should not be able to access that, because the objects or the bucket itself does not have any public privileges. So because of that, if you're trying to access that URL, we should be getting an error. Okay, so let us go and check that, and after that let us enable public permission to access files in S3 bucket, and then we'll try to reload it again. Okay, let me open another tab, paste the URL there, press enter. So you can see access denied. Okay, and got an HTTP error code back, that is 403. So 403 means forbidden. We are not authorized to access the site. That's the reason we are getting all this message. So now let us go and enable permission of S3 bucket for public access. Okay, click on permissions. You can see two types of permissions here. One is access control list. Okay, access control list is basically for object level permission. For example, you can give permission to each objects in the file, and bucket policies for the complete bucket. As we are hosting a website here, user should be able to get access to full files basically. So if you are giving access control list permission, then we need to give permission to each and every file whenever we upload. That'll be quite difficult. Instead of that, what we can do is to give create a public policy, and once we create a policy, whenever somebody basically the bucket owner uploads the file to the bucket, then he or she don't need to give object level permission each and every time. Okay, so let us create a bucket policy. Here there's a policy generator. We can generate a policy. Click on policy generator, and which type of policy? For us, that is S3 bucket policy, and principal, that is star, because we are going to give full permission. Full permission means for the public. That's why we have given star. Okay, and we need which action? We need just read-only permission. Because of that, we will give permission only for get object. Select that one. Okay, and Amazon resource name, that is basically our bucket resource name, that is this one. Okay, and paste it here, and we need permission for all files inside that bucket. Because of that, say slash and star, add statement, and generate policy. So this is the policy, basically that's JSON. You can see here action S3 get object, effect allow, principal star, that's for everyone, and all objects inside that bucket. Okay, so let me copy that, close it, and paste it here, and save it. Okay, now if you're trying to access the site again, it should work fine. Okay, let us go and check that. So let me go and copy the URL again, this guy, copy it, open another tab, paste it here, and there you go. Now we have hosted our site in production. The entire world can access this URL. Okay, you can give your own URL instead of AWS generated URL. There is another service available called Route 53. Okay, that's a paid service though. There you can host, basically if you have a domain, you can redirect to your own domain instead of this one. Okay, so anyway, so the next bit is obviously to search with the key. We already have one record in DynamoDB. If we search that, we should be able to get that data back here. Okay, so let us try that now. So code with Vijay at gmail.com and get customer details. Okay, it is still fetching, I think. Yeah, there you go. So this is the data that we have, we already have in DynamoDB, and that is working fine. It means our first operation, that is get operation, full end-to-end, is working fine. Okay, let us go and add a couple of more records in DynamoDB and see is that loading or not. Okay, so let me go to AWS console again, and let me add a couple of more data in DynamoDB. So DynamoDB here, and click on tables, customer details, and items. So let us copy this record action and duplicate. There we can give, say, test@gmail.com, and first name is hey, last name is, say simply this is a test. Okay, save it. Okay, let us create another one, duplicate, say test1, and we can say this is another test, for example. Okay, save it. Okay, now if you are trying to search with test1@gmail.com, we should be able to get that data, and if you are searching with test@gmail.com, then we should be getting that data. Okay, let us go and check that. First is test@gmail.com. There you go. This is a test, and email is test@gmail.com, and let's try with test1@gmail.com. There you go. This is another test, and test1@gmail.com. So I have committed the code to GitHub, so you can download from here. So play around, try it on your own. Okay, and the front end part you can clone from my GitHub, and you can just change the get API URL. Okay, so it is there. Alright guys, so that is the end of part 1. Stay tuned for part 2, and the most important thing is, please don't forget to subscribe the channel so that you will get notified when I upload the next part. Hope you guys have enjoyed the video. So we have built a web application that is 100% serverless. We did not spend any time at all to set up any server or anything like that. So we have built totally 100% pure serverless web application. Okay, so thanks for watching, and once again stay tuned for part 2. Okay.